Well, I've been talking about this for a few days because I knew it was in the stack of repairs, and it's the Midland 76900 base station. That has been given the kiss of death. Someone has decided that they know best, and they've illegally fitted an 80 channel conversion board. It's not licensed for 80 channels, and inevitably the radio now doesn't work. This is coming from another engineer in Yorkshire, and it's on behalf of a customer, but he didn't want to tackle it. So normally we'd go through a performance check before service, and you know, you just can't believe that someone would have a £369 base station and then, for want of putting CPT channels on it illegally, ruin it. It just doesn't compute to me. But there you are. So we're going to have to, don't know whether you've got to take the, don't think you do. We're going to have to take everything apart, because if we can get it to work, we'll do the power supply as well. Normally I'd start with the power supply, but we won't do on this occasion. I'm going to get a tub to put screws in, because there's going to be a lot of them. Well, we didn't have to go far to see the junk, did we? I've no idea what. I think you know, if we can get this to work, where have I put the glasses? That's frustrating. I'll have to find some other ones. They live on this bench. So the other side of this is that they're going to have utilised one of the switches to do this. Like, move the mains fuse holder and not secure it properly. Well, I think the easiest thing to do without a pair of glasses is to cut all these wires and put this in the bin. "1985" the printed circuit board says on the bottom. I think the best thing to do is to put that in the microwave and destroy it, and then put it in the bin. I just hate illegal things. So what that does is does away with the synthesizer chip, the LC7137. So of course the first thing we've got to do is to provide one of those, and the fun side of that is, of course, they're now expensive. Well, I think they always were. I think it's $16.50, $16.99 the ones we've got, and you know, at least we've got some. At least they're genuine, and tell that because of the tarnished pins. I think that fuse holder probably goes there, because if you look, it's got a little spigot there. So it looks like it should go the other way around, like that. I think we'll run this set on 12 volts when we're working on it. and worry about the power supply later. Why is that screw not wanting to respond to my screwdriver? I think we're going to have to deal with the screw as well, so I'll temporarily put that back. And wonder what switch they've wrecked. Looks to be, if we look here, it looks like it's been put on the N switch, which is the dimmer. There's a bit of front case inside, which must be a tab, so there we go. So back with taking the radio apart. So legality aside, I've never seen any of these modifications work properly. It's a compromise anyway. And they usually end up killing the radio, just like this has. Now we do have the model specific service manual for these. It's on the trader's service sheet in the 4000 series, but I don't think there's going to be anything on here that we're going to need that for unless we get into hot water over what they've done with their silly additions. Now this customer said he was going to send an audio line as well, which he did, and I was quite surprised when I opened the box and he had sent the audio line, and the audio line turned out to be a base station. Now another forthcoming attraction we've got is we've got a Uniden base station. So how about that, folks? We've got an audio line and a Uniden, so same minutes, but it's not often that happens. I can't understand why the glasses have gone. I'm going to have to go on a mission. Right, I've gone back on one of my previous videos when I did David's 76900. We had the bottom off to do the power supply capacitors. So I've now got this the other way on for convenience this time. So you can see I have actually behind the scenes mounted that fuse properly. So I wanted to check whether the wiring went somehow round the other side of the board, and it doesn't. The wiring for the LC7137 is done here, and hopefully we've got enough detail to put the wires in the right place. The other thing I want to look at, there's a diode here. It's just off the screen. I'll have to move the camera down. So just here there's a glass diode. There. And is it there on this other set? Well, I can't actually see it. One end is to that. Hang on, we'll just go back to a normal picture. So on this set as presented, we've got one side of the diode to that pad there, and the other, put those other glasses back on. to that pad there. I don't know why. It isn't on David's set. So the other afterthought capacitors, there and there, yep. The links, yep. All these other afterthought capacitors, apart from that one. No, that shouldn't be there. Now we could open up our own sample set of these, but that's costly in time. Hence doing a video frame off my previous video. So if that turns out that it should be there, we can always put it back. I was also looking for cut tracks. The only part I can immediately see missing from the other side is the coil. Sorry, not the coil at all. The trimmer capacitor. So the only obvious thing is that CT2 there. That's all I can spot missing. So this is our last LC7137, so the customer will have the choice of paying for this or replacing it from a UK supplier. So it's file the pins time. Drop it in radio time, solder it in time. If you've got access to LC7136s instead of LC7137s, well, you've got the double spacing so you can fit those. I can't see any distress capacitors on here, though we will be working on the power supply later. So I'll pause the video and I'll solder this in and we'll start fiddling with these wires. Right, so there we are. We've got that all cleaned up. New chip in. Let's just zoom in and you can see soldered all these wires back on where they should go. The chip's in and the missing trimmer capacitor has been replaced as well. So now for the moment of truth. We'll put that on one side, my piece of paper. You see my previous videos are useful to me as well. I'll just connect this up to my power supply. So rather than use the main supply, I'll do it this way, then we can monitor current and all that. So negative is that post there, which you can't see because I'm zoomed in. You can't see now because it's off the camera. Negative post is just there, and the positive post will use that tag strip. There we go. So power supply on. We'll start off at low voltage and low current. Now then, how does this work? Right, we'll get our, we've got 385 milliamps, that sounds alright. We'll go to 13.8 volts, 1.6 amps available. There we go. And we'll dig out our Cybernet mic, which we used just yesterday. internal speaker, normal, RF gain, mic gain, tone, tune, squelch. Not actually got any receive audio. So I'll plug the test equipment into the aerial socket. To be honest, I'm not expecting it to work. There's bound to be something that's overlooked, because I'm not quite sure, of course, what they do to these things. So we'll put the signal generator for 27.79125. And if it doesn't work, we'll go for a lunch break. And if it does work, we'll go for a lunch break. Oh, there we are. Right. 100 microvolts, so it should be an S9 signal. Turn the signal generator off, turn it back on, nothing. Press transmit. Put picture in picture on so you can see, and press transmit, and nothing. So of course we're not surprised. Now, of course, it may simply be that the VCO is out of lock. We'll get my £16.95 little multimeter out, shove it in the works, like you'd expect. Use Mr. Chippy's green crocodile clip lead, which he still doesn't know I've borrowed. And earth is normally the strap across the it's not there, is it, on this version? I'll pick an earth up that way. So resistor 4, needs to be on channel 40 for this, but it's not like it's going to work, I'm sure. I'm just going to check we've actually got a proper connection. Just find somewhere handy to read that from. Power input choke. Yeah, we've got 13.8 volts, so it proves that we've got an earth. So we're in transmit, and we've got 600 and something millivolts. So we're in receive. We'll do receive first. No, that's not getting anywhere, and on transmit. I mean, it may not even have any power up to the IC anymore. Where's that Binatone 5-star we sent Radio Cruncher once? Resistor 103 is missing. It may not be needed, it may be needed. So resistor 103, clearly does some power feed thing. I don't know whether it's never been fitted or you know what. So monitor both ends. There's no power either end, so it's never been fitted. So what I'm going to do, we'll have lunch and then I'll have a look as to whether we've got power onto the synthesizer chip. You see there's a part missing just here, but should it be missing? Have another look at that. It's detective time. Capacitor 123 is missing. So capacitor 123 isn't missing on the Binatone 5-star. So I'll tell you what, we'll recover this off the Binatone 5-star. I mean, for all I know, this couples the entire synthesizer to the rest of the set. I'll switch it off for now. I'm sure it should be fitted. If it's on the Binatone 5-star, I'm sure it should be on here. So it's just detective work. Trying not to drop it in the works. So what I've discovered is I didn't actually end up fitting that used capacitor. I've looked at the service sheet, the trader service sheet, and where that is in the circuit, stand up because I hope this is auto focused onto this. So from the synthesizer we've got capacitor 1, 2, 3. One of these will be transmit and the other will be receive. I don't need to bother which is which, but 1, 2, 3 is the capacitor we've just changed. I've put a brand new 47 picofarad one in, and transistor 10124 is also missing, so we're just going to put in 124, which is 18 picofarad, and the printer's still printing the 4th double-sided page. So we'll just get a new. They're just disk ceramics, these, but it looks to me like that's what couples the synthesizer to, can't say that, to the rest of it. So let's pull one of these out of stock. And what are they, 6p each? So no wonder it's not doing anything. I'll just clean the leads of these because I've had them in stock for about 10 years. So we're going to do the fiberglass brush on these. So there's 24. Soldering it on its side, otherwise obviously it could easily fall back out, couldn't it, before I've soldered it. So picture of me doing nothing. Right, so back to where we were. Switch the radio back on. And see whether we've got any difference on test point 4. Well, we've got a difference because nothing's connected. To be honest, no, we haven't. So it's still kind of free running by the looks of that. Just try with transmit. This is probably even no power on the So I've got a sneaking suspicion there's a resistor missing, 103 down there. Just see if there's, I'll tell you what, we'll just see if there's power on pin 18. So pin 1's the one with the dot. It's a 20 pin device, so go down 2 pins. Have we got 6 volts? We have, yeah. Oh, right, okay. So that's fair enough. So into transmit. See whether we can get anything. And the answer is no, we can't. So something else major is missing. We know 103 is not there, but should it be there? So we'll just have a look through these circuits and see whether 103 should be there. Well, it isn't on that page. And it's not on that page. See what's on the printer. And 103 is not showing on this page either, so, you know, barking up the wrong tree. There isn't a 103 by the looks of it on this set. We need to find out what else has gone missing. I'll pause the video and have a look. Right, we've discovered another 2 parts missing. Resistor 2, 10k, and resistor 1, 56 picofarads. So, you can't just think, well, there's all these parts missing, because the printed circuit board has different options for different radios. So, you know, it's not like every part should be in there, because that's not the case. So once again we've had to use the trader service sheet. Solder that one in, and I think we might have a fighting chance. We buy these kind of parts, resistors, quite an expensive way using the comp card system. So they actually work out about 24 pence each, which is ridiculous, but it's the convenience for us. So, it's 0.6 watt, 1%. Right, we'll power it back up. Still don't know why there's no audio on receive, but you know, we would expect a hiss, wouldn't we? You know, I think the next thing to try in that respect is to see whether public address works. Right, so rig the meter back up. Let's check that test point 1 again. Now we've got a totally different kettle of fish. That's more like it. So let's see whether that will set now. You know, folks, it won't. I've got high hopes for that. Let's try the transmit side. Am I actually on that? So we've got permanent logic high. Now why would that be? Well, back to looking behind the scenes. Right, so by careful adjustment we now have transmit. So I'll switch picture in picture on, so you'll now see RF being delivered, which is more than 3 watts, and that's 279912. Well, it'll be 5 when I've adjusted the trimmer. There we go. Just got my monitor receiver on. Testing 1 2, testing 1 2. So the very thing this thing had stopped doing was transmitting, and that's now restored. So that proves our synthesizer's working. Let's go to channel 1 and we'll look at the frequency there. 2760125. That's absolutely fine. You can't quite see that, there's a box in the way. There we are. So we've got that, but I can't see any meters. Oh, hang on a minute. Have we got anything? So if I tilt this up, I can't see any meters showing channel 20 in operation. So I don't know why there's no audio, but there's no audio. So I think the first thing to do on that, we'll set the VCO up properly later. We've got it working. So what we'll do, we'll plug the speaker, we've got an extension speaker mounted on the wall, into the public address socket. And we'll select public address. Testing 1 2, testing 1 2, 1 2. Dirty pot. I have to borrow Mr. Chippy's service solve for that. Testing 1 2, 1 2, 1 2, 1 2, 1 2, 1 1. So I'll tell you what, I'll pause the video and we'll get that. Right, that's sprayed the control. Let's see whether that works. Testing 1 2, testing 1 2 3 4 5. And does that work with mic gain? It doesn't work with, so that's fine. Does tone work on it? No. So we know that the audio amplifier is working. So now I've switched to external speaker. And let's go back to CB. Ah, right, so we've got a hiss through the external speaker. So let's switch to internal speaker. So the radio's internal speaker isn't working, or has been wired so it doesn't work. Okay, so at this stage we'll work on external speaker. So we've got channel 20 on showing on channel 10 on receive. That's bizarre. Let's see where we are on transmit. Ah. You know what? It's me. It's me. I've got these two wires the wrong way around, haven't I? What a silly Billy. That's all that is. Because on Cybernet radios, they follow the resistor colour code. So it's brown for 1, red for 2, 3 for orange, yellow's 4, green is 5, blue is 6. Switch back on. Go to channel 20. So it's interesting that I had appeared to have got transmit. Well, it was working on channel 1 and channel 40, but the ones in between would be wrong. So let's now see what's happening. So with the frequency counter, we're on channel 20 on the radio, 2779125. Excellent. Let's check channel 1. 2760125. Check channel 40. 2799125. Back to channel 20. And we should now have got receive. We have. So I was scarily thinking there was another fault, but it doesn't bring the internal speaker back to working order, which may well be burnt out. Right. So there are other things to do. There's a lot of other things to do. We're going to be rebuilding the power supply, and we've got to sort out the fact that they used the dimmer to activate their illegal modification. So that's got to be restored on the wiring to the printed circuit board, which is going to be fun. Because I think we need to now just go through the set and do an alignment, keeping it on my power supply, and instead of the extension speaker on the wall, we'll now plug it into the test gear. So that, I'm doing this today because today I've got nothing else booked in. I don't have to go anywhere, I don't have to play any organs, I don't have to see anybody, and so I've been able to spend 4 hours on this so far. Otherwise, it would get done in 40-minute sessions over different days. And it may well. I may have to order parts yet. Right. So we can now treat it as a normal working radio. And hopefully we can set up the VCO. Now, this capacitor, I'm just not quite sure about, because it looks like it's been altered. And I wouldn't be surprised if that one hasn't been altered too. They just don't look original. So can I see what that says on it? It says, I think it says 22 picofarads to the trader service sheet, and that component got the horizontal one, you've got the resistor is capacitor 20. So capacitor 20 should be 22 picofarads. So there we are. It's just that these coils don't kind of seem to be in the normal range. That's more towards the bottom than I would expect, and it just makes me feel that perhaps some capacitor value has been altered, which I haven't spotted. But as long as it locks properly, that doesn't really matter. So here goes, channel 40. Let's go into transmit. Sorry, we need receive first, don't we? Yes, I'm glad you agree. So we've got 4 volts on the meter. Going to transmit. Oh, it's like that, is it? Disconnect the speaker. And we've got 2.39 volts. I'm not sure we're going to improve on that. You know what, folks, we are. And that brings it to a better position. Bit of feedback's my walkie-talkie. So, channel 40, transmit. What am I doing? What a stupid thought. I don't know what I'm doing today. Right, receive is the coil. Transmit is the capacitor. And of course they're interactive. So the best we can get is 2.5 4. So will it lock on channel 1? So in receive it's fine. It's supposed to be between 1.8 and 2.5, which it is. On transmit it's a bit low. It's supposed to be between 1.8. I don't think we're going to get that any higher. There's a component, somebody has altered a component, I just haven't been able to spot it. I'm going to have one more look. I mean, it will do at that, but it's not how it should be. I'll pause the video. So I've spotted this, which shouldn't be there. Let's just look at our... How's that got muddled up? So here's the... Oh no, look, the capacitor is there. And it's 39 picofarads. Yep, that's absolutely fine. That's how it should be. So I'm barking up the wrong tree. I'm not sure why that diode's there. I'm going to unhook one end of that diode. Just make sure the radio's switched off. Let's see whether that's altered the range of the VCO. So you just do not know what they've done. Interesting, now we've got no transmit or receive. So that might have restored where we need to be. So you're supposed to start on receive. Let's see whether we can bring the voltage up now. So we want 4 volts on receive on channel 40. It's going to transmit. Four volts. Let's go back to receive. 4 volts. Just turn this monitor receiver off now. Transmit. 4 volts. Channel 1 between 1.8 and 2.5 or something. Yeah, I'd have to look at the book, but receive is certainly there and transmit is now there. So that diode was the cause of that. So we've now got the correct VCO range. That is fantastic. I think it's going to end up being a part 1 and a part 2. So we'll go through the transmitter. So we'll switch to there. Let's see what it's doing. Channel 20. So at the moment it's doing 4.6 watts. So we still need to make sure these are peak because they've probably been altered to try and get in the middle of the 80 channels. No, that hadn't been altered. Slight adjustment there. The only fear I have is one of those cores looks broken. The centre one. Knights at Curtin and Lindsay have them for about £1.50. I'd hate to have to order one. So the whole idea is to peak this initially. So that already was at peak. This is the one I think's broken. It is broken. So I have got to get that clear. We can't balance the transmitter without that being done. I'm going to unsolder that white coil, see whether I can turn it around or what. Right, so I've got it unsoldered, so let's just see if we can zoom in on that. Right. Hopefully we can get it out from the other side. Now it's jammed good and proper, so we've got to break away some of the top. See if we can move it down. That's broken a bit of the top, which the broken. What I've done is to break away the broken bit of the broken bit. If you can understand that. Because it wedges in the threads. There might be enough of that to use, because like I say, I'd hate to if I've got to order these. So hopefully, if we put that in the other way round, there's enough of it to give us a peak. There's about 90% of it left. So actually, if we just look at that, so that is full length, and that's broken away, and that's broken away. Right, so I've got that in successfully the other way around from the top, so I'll solder that back in. So hopefully now we'll be able to get a peak on it. Switch radio back on. So this may have affected the first coil. Peak 4.5 watts. Peak 4.9 watts. Peak 5.1 watts. So it's L4 clockwise for 4.4 watts. And L9 anti-clockwise for, they say, 3.8 watts, but of course UK residents are entitled to 4 watts, and 4 watts we're having. So now we need to check it's within 0.1 on channel 1 and 40, if I've got all that balanced right, and if that centre core is good enough. So channel 1, 4.05 watts, channel 40, 4 watts dead, so that's fine. Done it. So what did they got it on? Was it something like 4.4? Because they just tuned it up for the maximum they could get, which is ridiculous because it'll only do that on the actual channel. It won't balance out. Legality aside, of course. And that extra half a watt on that odd channel they've got it to do that on will get them probably an extra 100 yards if they're lucky. So I'm also concerned that something's linked out on the underneath the board here regarding where the deviation control is. There seems to be a link right where the deviation control is. So I'm just going to get rid of that link. Before I take that link out, let's see what the deviation is. That will be funny. Wow, actually it's 2.9, so that's not stupid, is it? It's over the top, but it's not stupidly over the top. So get rid of that. Perhaps there's a duff. What's missing there then? So that's left 2 holes. Just can't see them on this side of the board. I'm just going to poke some wire up it so I can see where that's coming out. See where that is. I've got to pull it out now. Oh yeah, right. It would go to resistor 98 at one side. And it would go to jumper 21 at the other side. How bizarre is this? Let's look at our reference Binatone 5-star. So that doesn't have either of those components in. So let's see what the deviation is with that link removed. Wallow. Well, it's now higher, so right. So we'll get this balance right. So we'll set that to the central position. That's the kind of feedy backy control, and then we want the deviation. Get the little oscillator out, which is the chord chromatic tuner we use. Just drop that deviation probably about there. Let's see how that works. Wow, it's spot on, that. And now we'll listen to that on our monitor receiver. Say 1 2 3 4 5 5 4 3 2 1. So that's fine. Right, the RF output meter needs to read 4. So key the radio up, and it bangs across beyond 5. It's had the psychological tweak up, so it wants to be, actually won't go any lower than that, so it's showing just under the 5, but in fact, of course, we know it's 4. And I'm not going to start altering the radio's resistors to make that read true. So on low power, the radio should be developing 400 milliwatts. I've switched the test set to low power, so it's now the 3 watt scale. So put the radio to low power. Let's see whether. Oops. Let's see where that is. Well, low power is doing 2 watts, so we'll adjust that so it's 400 milliwatts. There we go, 400 milliwatts. Back to high power, back on the high scale range. 4 watts. Fantastic. Well, I think we've done everything there is to do on transmit. So we'll now move on to the receiver. Oh, just while at it, I'm just going to check the internal SWR meter. Because the test set's got a dummy load in, of course. So transmit. Calibrate to set point. Yeah, that's okay. It's just moving it. So that actually works, which is nice to know. So we'll start with the detector. I'll tell you what, we'll just do a little performance check. Let's put that onto the synod meter there, and we'll get enough volume for meaningful reading. And let's turn the attenuator down until we get 12 dB. And at the moment, in fact, it's doing 0.52 microvolts. 0.52 microvolts, which is fine. So Let's go back to S9, 100 microvolts. Let's put the oscilloscope on and check the detector. Bench light off so we can see what we're doing. Detector coil. Absolutely spot on. So that didn't need anything. Turn the oscilloscope off, save my 18 watts, and go over to the synod meter. So I want about 4 dB, so the radio's not being saturated. You know, we've got the extra receive circuit. On the base stations, you have an extra receive circuit, because on the Rotel 220s and the York 861, you've got one bit less than the Rotel 230s, the Rotel 240s, the Harvard 420 amps. In other words, the lower range Cybernet 134s have got one receiver bit different to the higher ones, but the base stations have another one still. So this is the same as our Harrier CBHQ. We've got that extra coil there. I can't remember whether the York 869 has that other base station. So here goes. Will we get anything more out of it? Worse? Worse. That was P. Oh, we've got a bit extra there. In fact, we're going to have to change scales. There's a bit more signal on for that one. That looks about right. Let's just go through those all again. Right, what have we got there? So for 12 dB synad, we now have 0.46 microvolts, which I think is about what we got yesterday on that York 861. And what we got the day before on the Harrier CBX. So they're all round there, and that's great. I'm just going to turn the signal generator off. Yep, that sounds right. So we're going to see where the squelch is. So I'm going to turn the squelch to full. May as well put this to the attenuator controls. And we're going to turn the signal generator up until we get 100 microvolts, at which time I want the radio to open up. So 1, 3, 10, 30, 100, it's spot on. Absolutely where we want it. Right, so we'll turn it now down to 0.3 of a microvolt. We're going to park the signal generator there and switch it to standby. Turn the squelch down, set it to threshold. Switch the signal generator back on. See when it comes in. So it's coming in at 0.45 of a microvolt, it's leaving about 0.38 of a microvolt. Never the best squelch in the world on this board, but it's competent enough and it's working a treat. So let's look at S9. on the signal meter. So we should now have exactly S9. It's a little bit high. We'll pop that down with the preset there. By the way, this squelch preset is that one, just in case we'd have needed to alter it. So there we are, S9. So as far as the radio goes, it's done. So what we've got to do tomorrow, and I think it's going to be tomorrow, is we're going to rebuild the power supply, and so there's the big capacitor, the small capacitor, and yeah, that's about it. I think we've got those all in stock, and then we've got to mess about with restoring the dimmer where they've taken the and knackered up the printed circuit board to put their illegal modification in. So we've got to also find out why the internal speaker's not working. Don't know what we're going to do if that's burnt out. Really don't. If I tell you what, we'll look at that now. So we'll go off the external speaker and we'll go into internal. So we'll touch the tip of my extension speaker onto the hot. Yeah, so that tells us that the speaker which is in there is open circuit, I'm afraid. So switch the radio off. What a shame. Disconnect it. Remember, it's the orange wire to the bottom, because I might quiz you all on this when I've forgotten. And we'll get this meter on it and see what it says. Just can't kind of hold that. See if that stays in camera. No. Let's try again. No, seeing it as a capacitor. That is a real shame. And of course, to get to that, the front panel's all got to come off. So I think it's 4" on these, so I'll worry about that in part 2. So this may drag on, and it looks like I may have to order parts. So far, we've spent about $16.50 on the synthesizer chip, and probably £1 on the rest of the parts. So parts-wise, it's not been expensive. I'm going to put it on the aerial and the extension speaker, and we'll do our usual flick round the channels. Plug the aerial in. Antron 99, 6 feet off ground level. Switch to external speaker. We'll flick round the channels. 19 Roger.
Roger, right?
Yeah, Roger, what's your 20, please?
Yeah, look at Navy, mate.
Roger, got you at Navy, you got Tango 21 at Ancaster, Roger.
Roger, mate.
Thanks very much. Well, I nearly fell off my seat. How often do we get Somebody doing that? Well, Navenby's about, must be about 10 miles away, wasn't it? I don't know what to do now. I'm all of a dither. Right, so there we are. I've got to do a lot of investigation as to how we're going to overcome the remaining problems. So that's working on my power supply, remember. Just for the record, it's drawing, and I'm still on aerial, it's drawing 1.5 amps on transmit, which is quite a lot, but this power supply looks hefty enough to do that. And because it's got loads of meters, hasn't it, and they're all lit up and that. So there we are. So thanks for watching part 1 of the Midland 76900 UK, a restoration from having had the kiss of death. At least the radio is now working, it's just the ancillaries that need sorting.